Good morning, folks. I believe that you guys had a wonderful weekend, and I want to also believe that we had a great time last week learning online. Today is my first class for this week, and we shall be looking at the third part of geometry lesson we've been taking since the beginning of this online learning. Today is 19th of May 2020, and our focus in this class or in this lesson shall be on parallelograms. Last week we looked at isosceles and equilateral triangles. We also discussed congruent triangles, and you've seen the proof or proofs to theorems 1 and 2. So this week we shall see more theorems, and we'll discuss more on parallelograms, like I've said earlier. So I want you to get prepared, get yourself ready, and make sure you have your writing materials by your side. Your exercise book, your pen, pencil, your mathematical set, and also your construction materials. Okay? So the objectives for this lesson is given as follows. At the end of this lesson, learners should be able to 1. Identify properties of parallelograms and related quadrilaterals, and isosceles and equilateral triangles. 2. Use and apply the equal intercept theorems. 3. Apply terms on riders and solve geometrical problems. All right. Terminologies. These are the terminologies we've been looking at since the beginning of the lesson on geometry. So I believe you've seen them before now. And the symbols are also the symbols. No new symbol is added yet. The symbols we've started looking at from the beginning of this topic. So I'll begin with this for today's lesson, the student's activity. Using a ruler and a pair of compasses only, construct a rhombus PQRS of side 10 centimeters and angle PQR equals 60 degrees. B. Draw the diagonals PR and QS to intersect at point T. C. Measure angles PSR, QPS, SRQ, and diagonals PR and QS. From your measurements, the following must be hold true, provided you complete your construction correctly. 1. Angle PSR should be equal to angle PQR, and that should be equal to 60 degrees. 2. Both angle QPS and SRQ should be equal to 180 degrees, 120 degrees rather. 3. The length of line segment ER should be equal to 10 centimeters, and that of QS equal to 17.32 centimeters. 4. Angles PTS and STR all be equal to 90 degrees. 5. Line segments TT should be equal to line segment TR, and QT should be equal to what? TS. So please endeavor to do this class activity right now. Pause the video, construct, post your construction with the summary of your findings stated by the side of the construction, all with pencils. Submit it privately, exactly the way I taught you how to submit your exercises, assignments, and any home form. All right. I want it submitted privately before the end of this lesson. Endeavor you carry out the student activity. All right. Now, let's now commence the lesson in full. So we have parallelograms and related quadrilaterals. Definitions. A parallelogram is a quadrilateral which has both pairs of opposite sides parallel. 2. A rhombus is a parallelogram with sides of equal length. 3. A rectangle is a quadrilateral which has all its angles right angles. 4. A square is a rectangle with sides of equal length. Now for the diagrams of these shapes, you can see page 38 of the reference text. And also, I'll quickly show you the diagrams on GeoGebra, all right? So you can all see this. The first diagram I have by the left of my screen is, the top left is a parallelogram. So we said the opposite sides are parallel. You can see this side, HI is parallel to side KJ, and side KH is parallel to side JI. And one more thing you have to observe is that the length of the opposite parallel sides are equal, and opposite angles are also equal. Do you observe? Can you see that? Good. Next, we have a rhombus. A rhombus is also a quadrilateral with equal length of parallel opposite sides. So the opposite sides are also parallel to each other, but they are equal length. The difference between a rhombus and a parallelogram is that the rhombus has equal length of sides, equal parallel length of sides, opposite sides, while the parallelogram has just opposite sides to be parallel, but not necessarily equal. So, but from this, a rhombus is also a parallelogram, okay? But it's a special parallelogram. Why special? Because it has equal length of opposite and parallel sides. Then opposite angles are also equal, just like that of a parallelogram, all right? Next, a square, or a rectangle first. A rectangle, we said, is a quadrilateral with, which has adjacent sides 90 degrees. It has all angles to 90 degrees. So you can see the rectangle, opposite side is parallel also and equal to each other. Can you see 14, ES is 14, QR is 14, PQ is 8, and SR is 8 in length. While the angles are all 90 degrees. Same thing goes to a square. So a square is a special rectangle. Why? Because it has equal length of sides, but all of its interior angles are also 90 degrees. So I believe you've seen this and you understand. A parallelogram, a rhombus, a rectangle, and a square. Please observe, take note of all of these features I've explained, because we are going to apply. We need them to solve some problems as we proceed with the lesson. Okay. So next, I'm talking about the fourth theorem. And the statement is given as follows. In a parallelogram, 1, the opposite sides are equal. 2, the opposite angles are equal. You've seen that in the diagram shown to you right now, just a while ago, that the opposite sides are parallel and equal to each other. Also, the opposite angles are also equal in magnitude. So that is the fourth theorem. In any parallelogram, the opposite sides are equal and the opposite angles are also equal. The proofs to theorem 4 and 5 will be done in a separate video to reduce the length of the lesson. I don't want to make, just to reduce the size and the length of the lesson, of the video. 5. Theorem 5. The diagonals of a parallelogram intersects one another. We saw this from the students' activity carried out. If you have done your activity properly, you will discover that the diagonals bisect each other. Go back to the student activity. Measure the length from any of the points, any of the vertices of the parallel of the rhombus constructed. Of course, we've just agreed now that the rhombus is a special parallelogram. That means the rhombus is a parallelogram. So take your ruler, measure from any of the vertices of the rhombus to the center of the rhombus. You discover that the length or the diagonals bisect each other, meaning that the distance from OB will be equal to distance from OD, from D to O. Distance from O to B will be equal to distance from D to O. Similarly, the distance from A to O will be equal to the distance from C to O. So please confirm this from the construction. This is the fifth theorem, which I said I promise I'm going to make. I'll explain the proofs of theorems 4 and 5 on a different video to try and minimize the weight of the video. All right, so let's go into some summaries of properties. So we want to summarize the properties of those 4 shapes that we saw earlier. The first one is a parallelogram. So in a parallelogram, the opposite sides are parallel, the opposite sides are equal, the opposite angles are equal, and the diagonals bisect one another. In a rhombus, all 4 sides are equal, the opposite sides are parallel, the opposite angles are equal, the diagonals bisect one another at right angles, the diagonals bisect the angles. Did you see that? So I want you to observe, take note of the difference between this 4th property of a rhombus and the 4th property of a parallelogram. For a parallelogram, we only state that the diagonals bisect one another. But for a rhombus, it bisects one another not just anyhow, but at right angle. So it means those diagonals, they intersect at right angle. And you also see that in your class student activity. Please confirm that. Summary continues. In a rectangle, all of the properties of a parallelogram are found. All of the properties of a parallelogram are found in a rectangle. That is, in a rectangle, the opposite sides are parallel, the opposite sides are equal, the opposite angles are equal, and the diagonal bisects one another. In addition, all 4 angles are right angles, and the diagonals are equal. Did you see that? All right, so please don't forget this properties. And finally, in a square, all properties of the rhombus are found. Did you see that? Then all angles are right angles and diagonals are equal. So from these properties discussed, if I claim that a squared and rectangle or a squared, rectangle, and rhombus are all parallelograms, I believe you should agree with me, agree with my claim, or you see that my claim is a fact. So please take note of these properties. They will be required or be needed in solving some problem under geometry that to do with parallelogram or quadrilaterals. All right, I hope you're following and enjoying the lecture. Okay, next, let's look at some examples. Example 1 says A, B, C, D, E, F is a regular hexagon with O at its center. Find what kind of quadrilaterals are ABCO and ACDF. Then 2 says ABCD is a square with center O. P is a point on the line segment AB such that the length of line segment AP is equal to the length of line segment AO. Calculate angle POB. All right, so I'll quickly show you the solution to that, to those examples. I've solved it in another application. So here are the solutions. Let's quickly run through the solutions. So here is example solution to example 1. So this is the hexagon A, B, C, D, E, F. All right. So that is the hexagon. Then we're told what kind of quadrilaterals are A, B, C, D. I drew this shape using GeoGebra and imported it into this my writing platform. So if you can, let's look at this is do I call it purple? The purple line from this point A, B, C, D, O. Can you see it? So this shape here, the shape there is what shape is that? From what you've seen so far. I'm talking about this shape from A, B, C, D, O, this shape. What shape is that? Correct. That is fantastic. So that shape is a rhombus. That is a rhombus. Good. So that is a rhombus. A, B, C, D is a rhombus. So A, B, C, O is a rhombus, while obviously A, C, D, F is a rectangle. So obvious. That is so obvious. A, C, D is a rectangle. I hope you agree with me. Look at the shape carefully again and try to see what I'm looking at or see what I'm seeing. All right? Very simple, very easy. So, like I said in the previous video, most questions that you see under this topic, under geometry as a whole, you need to do some construction or some sketching before you be able to answer whatever question that follows. Number 2, ABCD is a square with center O. So here's my sketch. ABCD, this is the square, center O. All right. P is a point on line segment AB. So this is P, such that AP, length AP is equal to AO. All right. Calculate angle DOB. So you see this dash and this dash, those two indicators mean they imply that the length of AP is equal to AO. And if they are equal, then what can we observe? So in the diagram above, OAP, the angle located here, is equal to 45 degrees. Why? Remember that we said the diagonals of a square bisect the angles. Did you remember that? So it means the diagonal AO, this if I should complete this, or let me say extend this line AO to point C, it's going to, you see that is the diagonal. So line AO is the diagonal of the square. Therefore, it will bisect the angle at A. And don't forget the angle at A is 90 degrees. So when it bisects, it becomes 45, 45. All right. So that's, I said AO is a bisector of angle at A. So that divided the angles into two equal halves. Then also, AOP is equal to APO, which is equal to X. So AOP, the angle here, this angle is equal to APO, this angle, and I represent those angles as X. So why are they equal? Because triangle APO is an isosceles triangle, and those are the base angles of the isosceles triangle. Is that taken? And therefore, x plus x plus 45 degrees equal to 180 degrees. Why? Because those are angles in the triangle. And when you sum the angles, the first theorem, the sum of angles in a triangle is 180 degrees. All right, so let's solve now. So x plus x is 2x. We take like terms, subtract 45 from both sides. So we have 2x equal to 180 minus 45 degrees. 2x equal to 135 degrees. Then dividing both sides by 2, you have x equals 67.5 degrees. All right, so that is x, but that is not the problem we have to solve. The problem is find angle POB, and angle POB is labeled y. Okay, so y, hence y is equal to 180 minus 67.5 plus 45 degrees. Are you seeing that? Plus 45 plus 45. So I went further to state that 67.5 plus 45 is an exterior is the sum of this interior angle A in angles in APO. That is this angle plus this angle. We add this angle here over here at A plus this angle over here at O, it will be equal to the exterior angle somewhere here. All right. So this is the angle that gives 67.5 plus 45. Do you agree with me? Plus 45, because we've solved for angle at O to be 67.5. This angle here is 67.5. Why this is 45? So when you add up this angle plus this, you get the exterior. All right. So and the exterior plus this angle, don't forget that OB is also a bisector of angle at B, meaning this angle is 45 degrees also. So when you add up this plus y, you should get 180. And to solve for y, subtract these two angles from 180. Simply do that, and that will give us, and that gave 22.5, which is the solution to our problem. Very simple, very, very simple. I hope my explanations were clear enough. All right, now let's proceed with the lesson. All right, so having said that, you've seen the solutions to the exercise examples. Now it is time for you to do your own exercises. I have one exercise and a group exercise. I'm going to group you. I'll group you and you solve this as a group. Then submit to me as a group. So exercise 1. ABC is a triangle and N is a midpoint of BC. A line through C parallel to line segment AB cuts the line segment AM produced at X. Prove that the line segment MX is equal to the line segment MA. Then for the group as exercise, so you have to submit this before the end of the class today, for the end of the lesson. For the group exercise, like I said earlier, I'm going to group you guys, and you all know the group you belong to. You solve as a group and submit. And you solve as a group, okay? I'm going to create a Zoom meeting where you describe or you explain your solutions. You pick a group leader for each groups, and the group leader will explain the solution during our Zoom meeting in one of the classes next week. Please take notes on the very first class next week Tuesday. So take notes. And here is a question. PQRS is a parallelogram. Line PS is produced to a point X so that the magnitude of PX is equal to that of PX is equal to that of PS. So segment XR cuts PQ at Y. Prove that Y is the midpoint of PQ. So whatever group you find yourself in, you work as groups or as a group and you produce the results. Like I said again, I'm going to schedule a Zoom meeting where you will explain the solutions. You'll be given maximum of 2 minutes, let's say 3 minutes, to explain your solutions. Please get prepared and get set for this group exercise. Having said this, I'm going to end the class at this note. And this is the part 1 of this video. I will do the second part to conclude this lesson on Geometry 3. Thank you very much for watching, and I hope you had a wonderful time learning. Please submit all your exercises before the end of this lesson, except this the group exercise, which is due next week. Thank you. You have a nice time. Enjoy yourself. All right. Catch you.